Hey guys, and welcome to my channel, Educational Minds Hub. Today I'm going to be talking about the Pythagorean theorem and the law of cosines. So, normally these two things are taught separately. They both are in the same trigonometry, and Pythagorean theorem pretty much branches off into like distance formula, since the distance formula is based off of the Pythagorean theorem. You know, this formula. It basically branches off into the distance formula and all. So it comes up in like pre-algebra, but then you go into more depth about it in trig, basically. And law of cosines is usually taught with the law of sines, and the not so much heard law of tangents and law of cotangents. Basically, they're taught separately, but since they go hand in hand, I'm deciding to make a video with the Pythagorean theorem and law of cosines being shown and represented together. So first, let me talk about the Pythagorean theorem. The Pythagorean theorem. So the Pythagorean theorem, it's this theorem proved by many people. If you're interested, just search up, proof of the Pythagorean theorem. Khan Academy has 2 videos about it. But anyway, so, but Pythagoras was the one who came up with this theorem. He said for any right triangle, if you know two sides of the triangle, so let's say you know A, you know this side is A, and this side is B, and this side is C. So if you know A and B, you can calculate for C with this theorem. If you know A and C, you can calculate for B with this theorem. If you know B and C, you can calculate for A with this theorem. The theorem is A squared plus B squared is equal to C squared. So basically, what he's saying, let me copy and paste this triangle over. So what he's saying is that if you were to take the sides and then draw a square on it, that'll have to do. If you were to draw a square, let's make this more of a square. If you were to draw a square there, so if that was your square, if that's your first square, and then you drew another square here, the area of the two squares would be equal to the area of essentially this square, which would be associated with the length C here. Leg C. Yeah, leg C. It would be equal to the area of leg C. Of square C, I mean. Square C. So the area of that square plus the area of that square is equal to the area of that square. Actually, let me do this a little better. Let's use this. So imagine that's a square. That's going to be my attempt. So this square plus this square is equal. The area of this square plus the area of this square is equal to the area of this square. So basically, let's do a problem. So you're told that your A is 3. Your A is 3. And you've been told that your B is 5. I apologize. Your B is 4. What's your value of C? So let's use this theorem here. You have 5 squared plus, 3 squared plus 4 squared is equal to C squared. So 3 squared is just 9 and 4 squared is just 16. So 9, 16. So that means 9 plus 16 is 25 is equal to C squared. Are we done? No. What we have just calculated is the area of this square. So if you need to find the length of the square, the side length of the square, how do you do that? You take the square root of the area, right? So essentially, that's what we're doing here. To find that length, you have to imagine it as a square, as I drew up over here. So C is equal to the square root of 25, and the square root of 25 is just 5. So now we know that our C is 5. Let's do another one. So if we have a right triangle, and we are told that this side is 3, and this side is the square root of 5, then what is this side? So we have 3 squared, according to our theorem, 3 squared plus b squared, since we don't know what our b is equal to square root of 5 squared. So that's 9 plus b squared is equal to 5. B squared is equal to -4. So just by using this Pythagorean theorem, we know that this triangle is not possible. In real life, this triangle is not possible. However, I wanted to show you with the if you have a square root as the side, you square it, and then it'll just be square root of, if it's square root of a, square root of a squared is just a. One last problem. So, you are given a figure which I'm in the process of making. So, you're given a figure and you are told that you know that this side, the whole thing is 9. The whole area of this square is 9, and over here is 16. So now they want you to find the area of what would be essentially this square. So according to our theorem, a squared plus b squared is equal to c squared. So now you might be wondering, what? How do we use the Pythagorean theorem for this? Remember when I told you imagine a square, and that's what you're essentially doing when you're finding the third side? You're finding the area of a square, and then you're finding the side length of the square, which is how you find the third side. Well, that means a squared is just the area of this square. So you plug that in as 9, which means b squared has to be 16. So basically, you get 25. And 25 is your answer. You don't need to take the square root, because remember, when you get something is equal to c squared, you found the area of the hypothetical square that you could make around that leg. And when you take the square root of it, you find the side of the square, which would basically be this hypotenuse right here. Imagine it like that. So, but the question is, find the area of the square. So that means it's 25. I think that's enough on the Pythagorean theorem. Let's move to the law of cosines. That doesn't have anything to do with, Hold up. Law of cosines. So, let's say I show you a triangle. Let's say I show you a triangle. And none of his lengths, none of his angles are equal to 90 degrees. How would you solve this thing? This one right here. This triangle. How would you solve this triangle? That triangle. I'll give you a few seconds to think about it. Well, the law of cosines might sound pretty useful. So, here is the formula for the law of cosines. So, if you look at the image I just put, right over here is the formula. So, it's basically an extension of the Pythagorean theorem. It basically says if you know two sides and the angle in between them, because cosine of 90 is just 0, so that would cancel out this part, and you're just left with the Pythagorean theorem. So you need to know two sides and the angle in between them to calculate the third side of any right triangle, or not right triangle, non-right triangle, or right triangle. So let me give you an example question. We have our scalene triangle. We have this triangle here. We have this triangle. And if I were to tell you that this side over here is 3, and this side over here is 4, and this angle right over here is 45 degrees, how would you solve that? I'll give you a minute to think about it. So, basically, what you do is you plug it into the formula. So, what I'll do is copy, paste. So, we have c squared is equal to a is 3 squared, which is 9, from the Pythagorean theorem example, and 4 squared, which is 16, plus 16, minus 2 times 4 times 3, which is, so 4 times 3 times the cosine of 45 degrees. Of 45 degrees. Cosine of 45 degrees. So, that simplifies to, this is 25, and this whole thing is 12 times 2, which is 24. So we have c squared is equal to 25 minus 24 times the cosine of 45 degrees. Times the cosine of 45 degrees. So, basically, cosine of 45 degrees is 2 square roots of 2. So this whole thing just becomes 2, or square root of 2 over 2. So that means it's basically c squared is equal to 25 minus 24 times 2, or square root of 2 over 2. So this thing cancels and just becomes 12 square roots of 2. So then our answer, let me cut this out here. So we had c squared is equal to 25 minus 12 square roots of 2. So let's, if you're using your calculator, just follow along. Type in 25 minus 12 times the square root of 2. Square root of 2. And we get c squared is equal to, I'm going to go to the nearest, hundredth. 0.2. So then you take the square root, and here's where we deserve a drum roll. C is equal to and I'm going to round to the nearest hundredth. 2.83. If you guys want more practice problems, just Google law of cosines practice problems, or the Pythagorean theorem practice problems. Next video, I'll be going over the law of sines and doing a review of the law of cosines, since they are taught together. And yeah. So I hope you guys enjoyed this video, and see you guys in the next video. Learn on, everybody. Learn on.